Hi everyone, this is Eric Vanderwall, and this is the next part in the Substrate Recipes series for an introduction to Substrate. And again, the one we're going to be looking at here, just like the last one, is not actually in the Substrate Recipes. However, I feel like we should sort of stop here and do this first before we go on to the next part of the Substrate Recipes, because I think it'll make it a lot easier. Now, in this section, we're going to be looking at runtime storage. And runtime storage allows us to store data onto the blockchain that persists between blocks and can be accessed within our runtime logic. So what this means is, if you've been following along, and we add some kind of a storage onto our blockchain, we add it into our palette, we can go over to our polkadot.js.org/app, like we did before, as sort of a front-end abstraction. We can use that to access that storage. So it's a way to store items on the blockchain, essentially. Now, it comes with Substrate here 3 different ways to store this runtime storage. The first one is called a storage value, and I've been calling this simple storage. The next is we have a storage map, and we have a storage double map. Now, we're going to talk about the storage map and the storage double map further along. But first, I just wanted to talk about the storage value. And essentially what we're doing is just storing a single value, such as a U64, U32, or you know what, it could even be a struct. It doesn't have to be a primitive value, into a storage. So it's very basic and straightforward. Now, we also have the storage map, which we won't cover in this lecture, but this allows us to have a key value pair. So this is a hash map, and this is really common in pretty much all other programming languages, whether it's Python or C# or JavaScript, whatever it is, they all have their own hash map value. So this is that. Now, the final one, which is a little less common here, is this double storage map, and it says used as an implementation of storage map with 2 keys to provide the ability to efficiently removing all entries that have a common first key. So that's a little hard for my brain to read, but basically it allows you to subdivide or group items in different ways, and we'll look at that in that section. Now, in this one, we are only going to look at adding primitive values, because we'll look at dealing with structs in another section. But to be able to save a struct into your storage value, you do need some encoding and decoding to make that happen. So for now, we're just going to use primitive values. So that's what this talks about here. And it talks about the storage map, double map, iterating over storage maps, and things like that. Okay, so why don't we just jump right into the code. And I created my own palette for this. So if you don't know how to do this, watch the tutorial before this about creating your own basic palette. And in that one, I just duplicated the simple event. And I created one just called simple-storage. Now, in the simple storage, it's going to start out like the event one, where we've just configured the frame system here's configuration and added type event to it. So in this way, we can access events, which we're going to need. Okay, let me just clean this up a little bit so we can see better. Okay. Then coming down, the next thing we need to do is actually declare storage. So we need a macro for this. Just like we've used macros before for declare event or declare module, it's going to follow the same pattern as decl_storage opening and closing brackets. Now, you probably are sort of familiar with the basic concept of that by now. However, the next line here is something you would just have to memorize or copy and paste each time, because it's not going to be as intuitive. But we're using trait store for module, T as in type, configuration as simple storage. Now, what you should do right here is you need to give this a unique name, and I suggest that you stick with the name of this module or this palette. And what this is going to do is going to keep it from conflicting with other storage groups. So you don't want the simple storage in various palettes, because you might accidentally have a conflict here. So just give it a name, but I really suggest you stick with the name of the palette. So mine's simple storage. Okay, below that, we want to start declaring our storage. So you would declare all your different kinds of storage values that would be in here. So you're not implementing them yet. You just want to make a declaration of them. So we're going to say public because we want this accessible from other places. Okay, and the next is the name of your storage. So I can call this whatever I want. So I could call it, my number of friends. And we're going to pretend this is really high. And then we're going to say get an fn for function. And again, these don't have to match, but we really want them to do is we're going to say my underscore number underscore of underscore friends. So this is just following basic Rust and Substrate conventions of how we should write these. Okay. Then we're going to go double dot colon. Yes, colon. And then we're going to say the value of the storage that we want to hold. So if it's a U64, right, it could be like this, and we're going to close that off. Or you U16, or it could be, geez, I can't type today. Or, it could be characters or whatever it is. I'm just going to stick with the, say, a U16 just to keep things really straightforward. Now we can declare as many of these as we want, okay? And what this is the name of the storage value, okay? And what this is after function is you're declaring a helper function that will allow you to get the value of this storage. So we want to keep the names the same just for convenience sake so we don't get lost later. Okay, now that we've declared the storage, we could actually use the storage in some way. But before I do that, I also want to potentially, or not potentially, you always want to create an event to go with this. Because we want to send off an event at the end saying, hey, this was successful. Because just because we called something on the blockchain doesn't mean it's successful. So we want to create an event for that. We should also be creating errors for this, error events essentially. But we're going to do that in another lesson just to keep everything sort of siloed in our lessons and straightforward. So just like the event tutorial, and you should go back and watch that if you haven't, we're going to say declare event, and our events are basically enum. So we're going to say public enum event. And I'm just going to call mine value, we'll call this value returned, and we're going to actually return the value that was saved. So I'm going to call this, we'll add another one here for the U16, okay? And always with Rust and Substrate, we're going to end with this trailing comma. Okay, now we have our event declared, we have our storage declared. Now we can go ahead and start writing our actual declared module section. And this is where we're going to have our functions. Now at the top, because we are using events, we need to initialize the events. So we're just going to say function deposit underscore event, open and closing brackets equals default. Again, this is not standard Rust. You just need to know that this is something you have to use when you're using framework 1. And the first event I set up here was just simply to get the value. And like all events, or sorry, all functions, it needs to follow the same formatting. So first we need to give it a weight. And for now, we're just going to give it an arbitrary weight, okay? I'm just going to say 1,000. Then we need to declare our function. So this is standard Rust now. I'm going to say get friends. And with all events, or sorry, all functions, we need to get the origin at least. And then we're going to return our dispatch results. And so your IDE, like mine, may not catch any spelling issues, so you just want to make sure that's right. Okay, once we're in here, we need to say let to declare our variable. and I'm going to say user or caller or whatever you want. You should try and keep it insistent. We're going to say ensure signed origin to make sure that the person who's calling this has access, and then a little question mark after, because if not, we want it to error out. The next thing we want to do is actually get the value. So I'm going to say let and say my num of friends is equal to, and we're going to say self with a capital S. And what this is going to do is call everything that's in scope within this module and then within this palette first, right? Because we want to make sure that we're calling this here rather than from outside the palette if possible. So we're just going to call self. That will, it's like if you're using JavaScript or C#, it'll be similar to this, I believe. So this, so self. And what was the name, the convenience method that I gave here was called my number of friends. So I can just copy and paste this because my spelling is horrible apparently. Paste that in there. And since this is a function, we're going to have this open and closing parenthesis and semicolon to add this. And what this is going to do, then we're going to get my number of friends from this. Now we want to call the event to say that we've had a success and return it back to off-chain world. So we'll say self again for the same reason. And we're going to deposit an event. And this is event, not raw event, because it is a simple event. And we're going to use this friends return. And my friends return value is going to be my number of friends, right? And lastly, we want to give the OK and not an error message because it was successful. And we do not add a boop. We don't add this here because in Rust, if we remove this, this statement is going to be the return statement automatically, right? We could type return, if you're not familiar with this in Rust, and then close it off, and this would work, but it's not considered best practice. So we'll go like this, and it will return this OK statement. Okay, so this should work for us to just get the number of friends from the blockchain. It should be able to return that. Now, the next thing we want to do is probably be able to set the number of friends from the blockchain. We want to maybe increase our friend count as we get more friends, right? Everyone wants more friends. So we'll do this, and again, we'll just give it a wait. I wish my autocomplete would work here. We'll have to work on that, see what we can cook up. So fn for function, and I'll say increase num of friends, right? And just like before, we need that origin. We're going to dispatch those results. Check to make sure it's coming from the right person. Now, to increase it, first we need to know what the value is. So we have up here, so this one's working with just the primitive storage. This is the same, right? We're just copying this basically. So let the integer value equal self primitive. So get the self primitive, right? So let's just copy this line, but we don't want this primitive storage. We want our friends. This will return the U16 value. We do not want to run that function. Okay. Then we're going to say let my new friends is equal to this number plus 1. Okay, now we need to store this in. So so it was called my number of friends, I hope. Then we're going to use the put command. So put opening, closing brackets, and then we're going to say my new friends. And then we're going to close off this statement, okay? Lastly, we want to return an event. And we're just going to copy and paste the one that we used before. Because we're just going to use the same event. There's no problem with using the same event more than once as long as it fulfills the function that it needs. But we're going to use this myNewFriends as the return value. Okay, so that's it. That's how you're going to get and set values for just a simple primitive. Now, there are some other things you can do with it, and you can check through the documentation. But the most common ones here are you might want to clear the storage value. And like for a primitive value, it'll set it back to like 0 or whatever the default value is. So you would just want the name of the storage. You're going to have your : and you're going to use the kill event here, or the kill method. And you can also use a take, which is it's going to take a value from the storage and then remove it afterwards. So it's like kill, but you're going to take it out first. And so it's just the same, but you're going to want to declare a variable first with let to have it somewhere to be saved equals the name of the storage, : take as a method, and then that's it. So these are the main ones that you're probably going to see to just set, get, clear, and take. And I'm going to go ahead and save this. I'm going to run this, and then we're going to go to Polkadot.js just to make sure that it works the way we want it to. Okay, so my compiler did give me some errors, and I went back and fixed them. Now, I spelled origin wrong in a few places, as well as after this question mark, such as let_user equals ensured _signed. With the parameter of origin, it shouldn't be just question mark. It should be just question mark and then close off with a semicolon. So go ahead and do that if you are, following along with my code and you had some problems, and to make sure that all your spelling is right. Other than that, it did compile once I ran it. Now, what we need to do is go to Polkadot.js and have a look. If you get an error when you're trying to open up polkadot.js.org/apps and you are in the local development on a local node, don't forget you need to import your types under developer, or actually settings, developer. Yes. So don't forget to check this out. There's an earlier tutorial about it, but if you don't set this up, then you're going to have an error over here. Now let's go over to developer extrinsics because we need to call this function from outside the blockchain, as we're going to do here. And you can use whatever user you want. Then we need to select the module, and I was using simple storage. And you can see here all of the functions that we set up and the descriptions over here, which I actually didn't really change. So you should remember to do that as a best practice, of course. And let's go ahead and try and get the friend value. And we don't need to pass any parameters because we're getting something. And I'll click Submit Transaction and Sign. And now let's increase our number of friends. And once again, I will get friends. Now to see this, we're going to go to the Network Explorer and see our recent events. Click here and click here. So we have 0 as the first value because we started out with 0 on the U16. Then we increase by 1. And these are the return events, right? So we're using the return events to make sure that we return the value so we can see that it is correct. And ideally, we don't want to increase in value and then go to another function just to call it back and get it once again, because that's just a waste of a function when we could return it as, part of the return value. And if we look at the actual blocks here, we can see the event comes back right here, simple storage.friends returned, and it's 0. So this is on the first block. If we check the second block, we can see the return event here, simple storage friends returned. The value is 1. And I believe we called on the third time just to check again. and the value should still be 1. So that's basically how it works, that we can store these primitive values on the blockchain and get them out quite easily like this. Now, in another tutorial, we're going to look at how to do that using a struct. And we'll probably do that with maybe the double map or the hash or something like that, a little more difficult. Okay, until next time, this is Eric Vanderwall teaching you the Substrate introductions.